Hi guys, welcome back in this new tutorial. Today is going to be a fairly different video than usual. See that rather as a documentation that can help you move from one engine to another or simply get the shading fundamentals of the engine of your choice. The main reason of this tutorial is a lot of you asked me what would be the equivalent workflow to achieve my previous tutorial about Megascan shading. So using something else than Redshift. Of course I can't make the same tutorial again and again, it would be very boring for me and a lot of work. So I figured I had to do something so you can at least translate some workflow into the engine of your choice. Just to be clear, I'm not here to argue which one is the best. I couldn't care less about that actually. Nowadays everything is able to achieve photorealistic result. Now your choice might depend on your taste, pipeline, also your hardware. In my case, I've been using a gaming laptop for my personal projects and tutorials, so a GPU engine like Redshift was the best fitting my needs. Now in production I also use Vray, Renderman and so on, but I'm always curious to see what's out there. Obviously there are so many different engines that I had to make a choice. So today I'm going to focus on Mantra and Karma, which are integrated by default within Houdini, so there is a high chance that you may need to use it at some point. We have also Pixar's Renderman, which is a pretty powerful combo with Houdini since it handles USD and Solaris. Also, side note, you can use Renderman for free for non-commercial projects, so no excuse to try this out. We'll also see Redshift, one of the promising GPU engine on the market and my personal favorite because very straightforward and powerful. And last one will be Vray because it's being used extensively in the VFX industry and is now compatible with Houdini. I used it a lot in my career with 3ds Max, Maya, so quite excited to try this a bit more in the future with Houdini. Chaos Group offers 30 days for free. I invite you to check this out if you're interested. We won't talk here about Octane, Arnold or 3D Light, but they are perfectly running on Houdini as well. Alright, let's get going. I'm gonna head into the material tab and create the material builder for each engine. Of course, feel free to pick the one you're interested in. So this one's gonna be for Mantra Karma. And what are exactly the material builders? It will be basically a container for shading information, textures, nodes to keep everything organized. So let's add one for Vray. And we'll also have Redshift. Gonna rename that properly, material builder. And yeah, we are good to go. So the advantage of those material builders is that we can expose parameters to access certain function from the root of these nodes, and we don't even have to dive in. So let's get into the Karma ones first, and we're gonna create the base material, which is called in this case the principal shaders. So by default surface output is connected, but we're gonna move that to principal shader. It's important to keep it for layering though. So let's move with the displace, and we're gonna connect the position to the output P and the output normal to the normal. Alright, that's the basic structure. Let's do the same in Renderman. So we have an output collect as well to plug our shaders, and we're gonna create a Pixar surface, which would be one of the common shaders for Pixar, I guess. And let's create a Pixar displace. So this one would be connected in the second input. Easy. So same deal, now we're gonna do that for Vray. He already connected a Vray material. We just need to add a displacement to connect to the surface. For Redshift, same deal, we already have one material. We just need to plug the displacement. So we can unfold all the parameters of the shaders if we want. So it's using, like everything is using the same thing, diffuse, reflection, etc. Just gonna rename that properly so that there's no confusion. Let's talk about geometry parameters now. So in Houdini, you need to generate some parameters to be able to tweak the displacement and different attributes. So for Vray, you would have this icon, displacement properties, that would add all the parameters needed to deal with the subdivisions, etc. For Redshift, we would need a object params, this one. And as you can see, well, it was already added by default, but it's important that all of these are here, and you enable the tessellation and the displacement if you want to use displacement. So there's also a bunch of other options. Let's keep going with Renderman. We have add pair parameters, and in this one, we want to make sure that in primvar we have the enable displacement enabled. Sometimes you have to turn it off and on to make sure it works. Maybe it's fixed now. And also smooth normal can be a pretty important feature to make the displacement work. For Mantra, it would be into the dicing tab and get this to full pre-dicing. All right, let's apply our shader. We're gonna start with Mantra. So we're gonna set up a basic displacement with noise. All right. For Mantra and Karma, we're going to use a turbulent noise. There are many different types of noise, a noise, unified noise, etc. But I'm going to use a turbulent noise in that case. So let's plug that into the scale of the displace, and we'll also add a fit range. So I usually like to create a fit range to control the final output of the displace, and exposing a parameter that I'm going to call max displacement. All right, so pretty basic setup. And as you can see, at the root of this parameter, we can access this function now. So let's try to launch a render. And as you can see, the displace might be a bit too much. So let's reduce this max displace. All right, so looking better. We could try to play more with the frequency. So I'm gonna expose it as well so that we can access it here and try to play with it. So in that case, I wanna increase it. Okay, it's looking way better now. We've got some more interesting features going on. Sweet. So same workflow with Renderman. We will use a pixel fractal. So they all name differently, really. So that can be a bit confusing when switching from one to another. And same deal, I'm exposing the gain in that case, creating a parameter that I'm gonna call max displacement. And yeah, inside the pixel fractal, I'm exposing the frequency as well. So it's way too high as well. Let's increase the frequency, the max displacement. And also the noise is pretty smooth by default. So we might need to increase some features like can make that turbulent, increase the erosion. And I think the dimension might be too low. So this is adding quite a bit of detail. And the number of layers is the layer of noise you want to have, the complexity of the overall noise. So if you set it to 2, it's going to be a bit more simple. Oh, that's pretty interesting. One other interesting noise is the pixel whirly. Whirly noise is a type of noise that kind of creates some interesting ridges. So as you can not see yet, let's increase the frequency. So it creates some kind of cellular kind of structure, which can be very handy in some cases. And you can change this type to some kind of more universal type of noise like Manhattan. You got the Chebyshev and Minkowski, this kind of stuff. So some pretty basic but important feature to have, of course. All right, Vray time. Let's head into the matter builder, and we're gonna create a pattern for the displacement. As you can see, Vray put all the efforts to translate all the nodes they have in other software into Houdini. So we're gonna use a beacon noise that we're gonna connect to the displace. And one thing we can notice is that in most cases, we don't have a gear or any way to expose parameters, but well, whatever. Maybe they'll add that later, I don't know. Let's try to render this guy. Ooh, it's way too much. Let's reduce it. Okay, so it's a very simple noise. We're gonna make it a bit more complex. To do so, First, let's reduce the amount, and we're gonna head into the Berkon noise, and we have different type of noise, of course, Vray, etc. And we can use a fractal to add complexity. Now, inside the displacement, we're gonna copy the parameter amount and pass it as relative reference in shift, divide it by 2 and make it negative. So this way we have a centered displacement. All right, let's decrease that, and it's looking quite good now. One thing to point out is that by default, Vray is projecting this noise on UVs. If you want to turn that into proper 3D procedural, you might need to create a Vray UV object and connect that into UVW stuff. All right, that's looking better in my taste. Okay, so I think that's pretty much it for Vray. So pretty simple setup. Now let's talk about Redshift. And for this displacement, we're gonna use the new Maxo noise that has been added since I think Redshift 3. And we're gonna promote some parameters just like before, and let's call that max displacement. And we have a bunch of different noise. We're gonna use displaced turbulence for now. And let's render. So as usual, it's way too much by default, so let's decrease that. So the default light is pretty strong. Maybe I'll fix that later. Maybe I'm just gonna decrease the diffuse instead. Okay, start to see a bit more clearly. Might as well do a proper lighting, but it's not the point of the tutorial. So what was I saying? Yeah, we have the source. We can set it to object or world for the 3D procedural, and let's actually decrease that. Yeah, something maybe like that. Can try some more octave, more complexity, and I usually like Naki noise. It's a pretty good one. VL noise is pretty interesting too. Displaced Voro noise could be a good base for rocks as well. Then let's decrease that. One thing to notice is the displacement is not centered, I think. So inside the displacement redshift, we could set the new range min to -1. So this way we make sure that the displace won't inflate, but also create some negative space. Yep, seems to work a bit better now. All right, let's move on. So assigning texture to the shader with its corresponding UDIM is a pretty basic thing, but important thing to know. So in Mantra and Karma, we would use a texture node and plug the color output into the base color. Let's go and grab some texture. So I made that in Substance Painter just for the sake of demonstration. And so we got this first texture, which is one tile of the full texture. So we would need to import all the other UDIMs. So there is this little expression that we need to use to call all the UDIMs. So now it's displaying the colors properly. So let's do the equivalent with Renderman. Gonna get rid of that, and let's create a Pixar texture. This one. So it's pretty straightforward. Let's plug the result RGB into diffuse color, and let's grab the base colors that's created. So in alias style, you should choose the corresponding tag that fits the naming convention of your UDIMs. In my case, it's written 1001, which is corresponding to the Mari type of UDIM. I'm gonna add this little tag here, and that should work. I'm not even sure. Maybe you don't even need to add the tag and it will detect it automatically, actually. That would make sense. Yeah, but anyway, it's working. So let's keep going. Right, let's do the equivalent with Vray. I'm gonna bring a Vray image file, which is the equivalent of the texture node, and plug that into the diffuse. So I'm gonna grab the base color, and I got multiple UDIMs, so I need to add this tag to make sure that I will import everything properly. And let's launch a render. So that's great, seems to work fine. And yeah, by default it's sRGB. If your texture is linear, make sure you're using linear. In my case, it's a Substance Painter export. That's like 8-bit. So let's just keep it sRGB. It's not a tutorial about color space, but we might talk a bit more in depth in another tutorial. So let's see the equivalence with Redshift. I'm gonna create an Earth texture and grab the base color. In this case, we're gonna make sure to use this tag to import all the UDIMs. If you have UDIMs, you don't need that tag, of course. And I'm checking enable and sRGB just to make sure it's RGB. All right. Correcting and mixing texture, one of the fundamentals of shading. So for mantra and karma, I'm gonna do some basic color correction like a U shift. You can plug the color into the color input and plug that into the base color. I'm gonna try to render with the IPR, and actually it won't have any effect unless you increase the shift amplitude. So that's a little trick with this node. I must say I barely use this node. In general, I'd rather use a color correct. So color correct gather all other operations like saturation, value, and so on. So it might be a bit more handy if you want to quickly change the look of one texture. So in this case, I'm gonna try to get some kind of orange vibe like that, and we're gonna mix that with the original texture. So you have either a color mix or a composite node to blend your texture. So composite is slightly more advanced. You got different blending mode and stuff, while color mix is just mixing thing with a basic B over A. So something like that. I'm gonna make it simple, and we have this bias amount that basically show more or less of the texture. So I'm gonna blend that with a turbulence noise and plug that into the bias so that it's controlling this mix like a mask. And the fit range in that case is contrasting a bit the turbulence. Yeah, something like that. And if you increase the destination minimum, you reveal the original texture, and if you decrease, you're gonna show more of the color corrected texture, this kind of thing. All right, let's do the equivalence with Renderman. So we're gonna bring a Pixar color correct. So this will allow us to change the hue, the saturation, the brightness. You got a bunch of different features in here that can really help you control the look of your textures. And we're gonna use either Pixar Mix or a Pixar Blend. So the difference is the Pixar Blend slightly more advanced with different blending mode like in Photoshop. And we also have a Pixar Layered Blend, which does the same thing but can blend multiple texture, which is like very handy. So I want to make things simple so that it's not too confusing. It's like very beginner kind of tutorial. So I'm using a Pixar Mix. I just do a basic B over A and blending that with a Pixar Fractal. So the fractal will act as a mask. I'm changing a bit the hue of my texture just to bring some breakups so that we get some kind of orange kind of look in some places, and it's pretty interesting. So I'm going to use a Pixar remap maybe to contrast a bit more my mask. So let's make sure it's plugged into the input RGB, and let's use result R to bring a float into the mix parameter. Yeah, something like that. You can always play with turbulence and stuff to bring the breakups you want. All right, let's now see what we can do with Vray. And Vray actually has a bunch of different color correct. This one is, I guess, made for Houdini, but you also have the equivalent for Max, the color correct from Max and Maya. So if you're familiar with those, maybe it's more useful for you. For me, I'm like, whatever, I'm fine with this one. So I'm just gonna do some basic color correction and mix that with a Vray blend, texture blend actually. And we'll also have a Vray mix. So Vray mix, which is slightly more advanced. We've got some extra features for transition and stuff. And we also have a very layered texture. So this one can help you stack multiple texture. So that's pretty handy. You just need to click on the plus and then you have the blending mode and stuff. That's pretty handy, really. In this tutorial, I'm trying to make things as simple as I can, so I'm not gonna use those, but just to let you know that it's here, and if you need like to do some Photoshop with your texture, you can use that. Okay, so I'm gonna plug my blend, basic B over A kind of thing, and we're gonna use a Berkon noise that we're gonna plug into the blend, so that will be our mask. And let's use a Vray remap. So we're gonna contrast a bit this noise. Okay, one thing that can be pretty confusing is the remap node. We'll see a bit in a sec, but let's render that guy. So didn't change much. Why? First, let's make sure the blend is properly working. Okay, we got some U shift now. That can help. So we could also play with the brightness. So the brightness is a bit funky. I usually use advanced instead, and the brightness is acting more like a multiplier. In that case, it's more interesting to me. And yeah, now we got a blend that works. And yeah, let's plug the Berkon noise just to see how it looks like. So the frequency is not really interesting. I think that could work better. And we're gonna use UV object to make sure it's a 3D procedural. And let's add some turbulence or some fractal kind of thing to add some extra detail. Okay, maybe the exponent. So we get a bunch of different fractal that you can use. So maybe this size could work better actually. So low is more like a clipping threshold that can help you like remap very quickly. And if you want to use the remap, well, you can, but first either you use a color and you use the input color, and you can like remap your texture like you want. But in our case, we got a grayscale, which means we should rather use a value mode. And in that case, we need to plug the noise into input value. And now we can play with the color ramp, for example, to bring contrast and stuff. So that's a little trick to know about the Vray remap, I guess. And now we got our breakups. Can always play with the color of this remap so that we can see more or less of the different inputs of the mix. So in this case, I'm trying to attenuate a bit the orange thing, and yeah, something like that. So let's do the equivalent with Redshift. So Redshift actually got this node, the Golem HSL, which is a basic HSL controller that we're gonna blend with either a color mix, so it's basic B over A, or a color composite. So this one is slightly more advanced because got all this kind of blending mode and multiply, soft light, and so on. It's kind of a Photoshop. And let's plug those, and yeah, we're gonna blend those with a Maxon noise. I'm gonna set the type to Luca because I like it, and increase the scale. We may want to contrast this mask, so I'm using a change range, which is basically the equivalent of a fit range. And let's change the hue, lightness, saturation to bring some interesting breakups. And yeah, I think that would do. Let's maybe play more with the scale. Yeah, it's pretty interesting. And well, the new range max is basically the maximum destination value. So if we attenuate it, it would be slightly less orange. Also, side note, you can use a low clip or high clip to contrast your values. Well, personally, I kind of used to the change range node, but well, it's here. Also, you can use some color correct node if you need like more complex operation. Now, time to import some attributes and layer some shaders. So one thing, I created real quick an attribute called mask using my AL mask builder that you can find on Gumroad. You can actually replicate that with basic point VOP operations, really nothing tricky. So I'm gonna use this attribute to drive a layer of snow that we're gonna add on top of this toy. So let's go back into the material tab, and we're gonna start with Mantra and Karma. So we have a layer output on our shader, and basically we can also use a principal shader core, which is having only this output layer in this case. So if we want to layer those shaders, we should use a layer mix. You also have a layer composite that have some other options. So let's make this simple and just do a basic B over A with layer mix, and let's plug the layer output of those. So if you try to plug that into output collect, it's not gonna work because you actually need to compute the lighting, and we'll also need the surface output of the shader builder and plug the corresponding input output. Okay, so now we can actually plug the surface output into output collect. All right, so that's one thing to know about layering shader with Mantra and Karma. So now we have the alpha of the layer mix that control how much you reveal of the different shaders. Okay, so I'm gonna bring our attributes with the bind node, and let's plug it into the alpha. So now we got our mask driving the blending in of those shader. I'm gonna increase the color to something like white for the snow. So of course you can use any texture to blend your material. You can use fractals, you can use any nodes that generate data to blend your different layers. So in my case, I'm using an attribute, but could totally be something else. So let's layer some displace. I'm gonna copy this turbulence setup. Okay, and let's increase that. So we're gonna use it to displace some kind of snow buildup. And let's plug that to the displace and the P and normal. Okay, let's see. So it's way too much. It's still kind of crazy. I just realized I plugged the turbulence into the position of the displace and not into the scale. So let's not make that mistake. So it's working much better now. Then the displace is applying everywhere. So we want to filter this noise with our attributes. So I'm going to use a color mix and set the primary color to black. So basically no displacement. Let's plug that to the scale, and the bias is going to be plugged with the bind node of our mask. Okay, so now we have no displace in the first input. Like if we try to increase, it's getting crazy. So let's make it black. And the second input of the blend is this turbulence. So I'm gonna copy the fit range and plug that into the base color to bring some color breakups. And for example, we could refit the values to some kind of light gray destination mean of something around 0.5 to bring some little darker variation. So one more thing I want to flag is that instead of doing all this setup to layer the displacement, you could also take advantage of the layering system in Mantra to plug the displacement straight into the material because they got this displacement input. So that might be easier, and then in the layer mix you have the displacement mode that is doing all the job for you. So now the equivalent workflow with Renderman. So we have this pixel surface, but we may actually use a pixel layer if you want to stack material layer. So I'm gonna get rid of that, and let's duplicate this pixel layer, and this one's gonna be our snow, so I'm making it more like white. And we're gonna use a pixel layer mixer to blend those. So that's the first input, and the snow as the layer 1. Then we plug that into the input material of a pixel surface. So that might be confusing, but it's just a way to convert the shader. Otherwise, it's not possible to plug it into the output collect. Then we're going to import our mask attribute with the primvar, pixel primvar, and let's plug the result RGB. So it's not working mostly because I should use the result float instead. And now it's working properly. For the displacement, we're going to use a pixel displace, and we're going to displace a fractal. So let's increase the frequency, erosion, and add some complexity by increasing dimension. Then let's plug our displacement. That's too much. All right, let's reduce the gain. So that's much better. One thing we could do too is add some frequency maybe. And if we want to make sure to get some proper values, we could use a pixel remap. So let's see. Output range to -1. So it's not doing much, mostly because the input range might actually be not between 0 to 1, but -1 to 1. So what are we doing here is like we are not changing anything unless you remap that at 0 and clamp some values. But well, never mind. Was useless. Gonna layer the displacement using the pixel blend and plug that instead into the disp scaler. So now we have our mask that is limiting the displace in the snow area. All right, so let's reduce that, still way too much. And that's pretty much it. Let's move on to Vray. So Vray, just like in Max, got the Vray blend material. So if you ever used it, that may be familiar. So let's add some inputs, and we're gonna duplicate the Vray material that I'm gonna call snow. And let's plug that in BRDF2. I'm gonna apply a white color for the snow. And let's use a Vray user float to import our mask. So you can of course use any other texture to blend your materials, but in my case I want to use an attribute. So let's plug a displacement. Now we're gonna layer some displace. First we need some noise that we could use to make the snow build up. So I'm using a float to color just to make sure that I'm feeding the right information into my shader, because depending if it's a scalar value or a color, it might get funky. So color to float, and the float is going into the displacement. So we got our beacon noise, and let's decrease the amount. Okay, already got something decent. Now the displace is not centered by default though, I think. So let's copy the parameter and paste it as relative reference divided by 2, and let's make that negative. So that would be one way to center the displacement. We're gonna use the Vray texture blend, and actually this should go into the B input, and the blend's gonna be the mask attribute, like so. So that's looking better. Now it's shrinking the geometry of the rubber toy where there is no snow, mostly because the initial displacement value shouldn't be 0, it should be 0.5, because we centered the displacement. It means a value of 0.5 is equal to 0 displacement. So now it's working properly. All right, we could actually now use the noise to drive some colors. So we're gonna use the beacon noise and use a Vray remap. Let's plug that into the input value. Let's make sure it's input value, and plug that into the diffuse. So now if we refit that, let's put like a middle gray and render. So we start to see some color variations, pretty cool. Maybe I want to see more contrast, so could pretty much reduce that to something darker. Yeah, here you go, something like that. So let's move to Redshift. We're gonna use a RS material blender, and yeah, in here we just need to feed another material if we want to layer it. So this RS material is gonna be the snow. And let's bring our attribute with the node called RS scalar user data. That's a pretty wacky name. I'm just gonna rename that mask attribute to make it less confusing. And let's set the attribute name to mask. I'm gonna create a displacement blender so that we can layer some displacement. So we need to create an RS displace for the base input and for the second layer as well. First, I'm gonna set up the max on noise that we're gonna use to create the snow buildup. Okay, let's actually feed that into the base input and set that to 0 because we don't want displacement where there is no snow. And let's reduce the scale a little bit more, less. Yeah, we already got some decent result. Need probably to play more with the max on noise. Okay, probably less displace. So it's just a matter of finding the balance between the size noise and the displacement. Also, we could change the type to something else like Naki. All right. So I'm probably gonna rechange that again. And yeah, in the diffuse, we could also remap this with a RS change range. Let's make sure it's for colors though. This way we can just tweak this color to shift the values. So yep, that's how I would proceed with Redshift. Alright, it's pretty much it for today, guys. There would be a lot more to say about shading, but trying to keep it short. Maybe I'll do a second part with more workflow equivalence if you think it was useful. If it helps, consider subscribing. I check out my stats and 70% of people watching are not subscribed. What? As you wish, but you may be missing a lot of precious information, just saying. Alright guys, see you very soon for some more learning fun.